let me not lose focus because Ayaz has got me like excited now. All right, if I make x equal to 0 over here, I'm going to get y is equal to -1. Right, and if I make y equal to 0, I'm going to get 0 is equal to -2x minus 1. The 1 will go over to the other side and become positive. 1 is equal to -2x, and then I'm going to divide both sides by -2. -2. Therefore, x will be equal to -1/2. All right, so my two coordinates are going to be 0 and -1, and my other coordinate will be -1/2 and 0. Those are the only two coordinates we need in order to draw a linear graph, guys. We've spoken about this. Okay, the dual intercept method, we just make y 0 and we make x 0 and we find two variables. So if I put this on the graph at 0 and -1, this will be down here at -1, and at -1/2 and 0, that would be over here, -1/2. Let me make it a little bit bigger. I'm being so stingy. Okay, I've got a whole graph. Let me make it bigger. That's 1. And this over here, oh, I'm lying even. I should make this -1. And over here, this should be -1/2. Those are the only 2 points I need, -1/2 and 0, and 0 and -1. Then I can just use my ruler to join these two graphs. Okay, excellent, guys. All right, so today we're going to be learning about quadratic functions. And quadratic functions normally take the form of y is equal to x squared. There's always a squared involved. So as soon as we see the x squared part of it, as soon as we see the squared part of it, we know that it's a quadratic function. Okay, so we're going to take these three values, and if you're ever having trouble drawing, okay, when we're having trouble drawing our graph, we're going to use these 3 points. Okay, x is equal to -1, x is equal to 0, and x is equal to 1. So we're going to use these 3 points to plot our graph. So we're going to substitute into our formula. So I want to ask you guys, if x is equal to -1, what is y going to equal to? I need you to replace x with -1. What will my answer for y be? Good, Namani, that's it. It should be 1, because -1 squared will give us +1. Okay, if we take -1 all squared, there's going to be 2 negatives, and that will give us +1. All right, if x is equal to 0, what will y be equal to? If x is 0, what will y be equal to? No worries, Tarika, welcome. 0, good. Or is it Tyra? Because we have a Tyra and a Tyrika. Tyra, hi Tyra, welcome. Good. What about when x is equal to 1, guys? What will we get? If x is equal to 1, y will be equal to 1. Good. So we've got our 3 coordinates. Our 3 coordinates are -1 and 1, 0 and 0, and 1 and 1. Now, if we had to plot these on our Cartesian plane, we would get, I'm going to use a nice color, we would get 0 and 0, right? Because that's the origin at 0, 0. I haven't even written anything on the screen, and Zara's already like, oh, 1, and -1 over here, and then 1 over there. Okay. Then if I get -1 and 1, my x value is -1, my y value is 1, that they're going to meet over here. Yes, no worries, Askewele, yes, you can. And if my x is 1, my y is 1, so they also meet over there. So now I have to connect the dots, okay, to put them together. So over there and this way. Okay. Okay, Asikewele, what is -1 all squared? It's the same as -1 times -1, and that should give us +1. Okay, I hope that makes sense. All right, so this is my graph of y is equal to x squared. Right, now a couple of things have happened over here. Now I know that if this x squared over here, if I've got y is equal to x squared, there's actually an invisible 1 right here in front of my x squared. There's an invisible 1 here, right? it's also a positive 1. Okay, it's also a positive 1. So when this number that I'm getting over here in the middle is positive, my graph, which is called a parabola, this is called a parabola, is a smiley parabola. Okay, it's a smiley parabola. Okay, it's smiley. So because this number over here is positive, this number in front of x squared is positive, my parabola or a parabola, because it looks like a bow, parabola is a smiley parabola. Okay, now this is the original parabola graph. Y is equal to x squared. Now let's look at what happens when we start making things a little bit more interesting. Okay, I love it. Thank you, teacher Nels. Positive coefficient of x squared, smiley parabola. Excellent. All right. Okay, now let's see what would happen if we had y is equal to negative x squared and if y is equal to 3x squared. Hello, Tiana. You're a tad bit late, my sweetie. Just a little bit, but you haven't missed much. Okay, now let's look at what's going to happen if we use the same 3 coordinates, guys. Okay, now remember, we're not going to deviate from the 3 points that we've been using because they always help us. They always help us. Okay, sure, Akwando. Actually, before you screenshot, let's do this. Okay, I'm going to move this up here and we're going to compare the two on the same graph. Okay, y is equal to negative x squared. There you go. All right. Right, so now when we want to look at what this graph over here is going to look like for y is equal to negative x squared, we're going to use the same 3 points. We're not going to deviate. We're going to use x is equal to negative 1, x is equal to 0, and x is equal to 1. We're going to use the same 3 points again and again. Okay, so now I'm going to ask you guys, if x is equal to negative 1, what will y be equal to? Now, I want you to remember that if I replace x over here, I'm going to get y is equal to negative, open brackets, negative 1 squared. What is that going to give me? What will y then be equal to? Mnamani, be careful. Esona, you've got the right idea. Asavuya, well done. That's it, Randile. It should give us negative 1. Because this thing on the inside here, negative 1 squared, will become positive 1. And then you still need to take that positive 1 and multiply it by this negative on the outside. So my answer will then become negative 1. Okay, negative 1. Now, if my x is equal to 0, what will my answer be? Luandile, excellent, that's it. Y will then be equal to 0. Good. What about if my x is equal to 1? What will my y equal to? Y will be equal to, not 1. Remember, there's a negative on the outside, guys. If I replace this, have a look. 1 squared will give me 1 times the negative on the outside will give me negative 1. So we need to be very careful when we do that kind of thing. Okay. Make sure that that negative outside doesn't belong to the x squared. Do the x squared first and then multiply by what's on the outside. All right, now we can plot these 3 points. We've got 3 points. I've got negative 1 and negative 1, 0 and 0, and I've also got negative 1 and negative 1, not negative 1, 1 and negative 1. All right, let's plot these. I know that there's a point at 0 and 0 right in the middle. And then at negative 1, I've got a point at negative 1. My y value would be negative 1 there. So x is negative 1, y is negative 1. So they meet there. And then at x is equal to 1 and y is equal to negative 1, they meet over here. Okay. And then all we need to do is connect the dots. All right. There we go. That's it, Imelda. My turning point is at 0, 0. Okay, excellent. Now, what are we looking at? Jasmine, tell me about the coefficient or the number in front of x squared over here. What do we know about this number over here?
The number in the front affects the gradient.
Okay, in this case, would it be -1 or +1 over here?
A negative.
Good,
No,
it's a -1.
So
Good, so we can see from our parabola, what kind of parabola do we have? Is it smiley?
Sad face parabola.
Good, a sad parabola. Okay, a sad face parabola. I like the way you said sad face.
Because it is in quadrant 3 and 4, and the smiley face parabola is in quadrant 1 and 2.
Beautiful. Oh my gosh, your teacher's doing an amazing job. She even taught you guys the quadrants, which is great.
I learned this on my own, self-study.
Hey, look at you. Excellent.
Videos.
I love it. I love to hear it. Excellent. Wow. Jasmine, at some point, I feel like you're not going to need me. If I feel like you're not going to need me at some point, you're just going to be like, ma'am, you can take a break. I'll do the class today. I feel it coming.
Yes.
Very well done.
How do we say that Iki's name? How do we say it? A quadrant is the dots. I mean the sections on the graph on the axis where the lines lie, negative or positive. That's a quadrant, isn't it?
Yes, absolutely, 100%. So I think it's going to be better for Askewele to see it if I show her or him.
Yeah.
Okay, I'm going to show them quickly exactly what you're talking
about. And I hope
about.
that answered your question.
It probably did. I think it did. It's just going to take them a little bit, like I think visually, because on my side, I can draw on the actual thing so they'll understand it a little bit better. But Jasmine, please don't steal my job. I see you getting there. I see you getting there. Okay, Tiana, give me 1 second. I just want to answer Askewele's question quickly. So a quadrant, if you look at this Cartesian plane, it's literally split up into 4 parts. Do you see that? So these 2 lines split my graph into this part here, that part there, this part here, and that part there. Okay, and these are called quadrants, and they're named in a specific order. So this one over here is the first quadrant. Okay, this one over here is the second quadrant. This one is the third quadrant. And I'm guessing we all know that this one over here will be the fourth quadrant. Okay. All right, that's all that it means. And what Jasmine was saying is that if it's a smiley face parabola, it will be in quadrants 1 and 2 because it's smiley face and it's at the top. If it's a frowny face parabola, it will be in quadrants 3 and 4. Askewele, I hope that answered your question. All right, Ndwendle, I'm going to take Tiana's question quickly and then I'll take yours. Hi, Tiana.
Hi, ma'am. So, I just came late now because I just woke up. So I'm confused. What do we? Is this like what ma'am said last week? We're gonna do the quadratic functions and stuff.
Yes, this is a quadratic function. Yes, remember quadratic means that there's a squared. Okay, so we're looking at the graph of a squared function. And just hold on for me. Just follow the steps as I take them, and you'll see what I mean by that. Okay.
Okay, thank you, ma'am.
All right, excellent. Okay. Excellent stuff. I see somebody asking, Nyeleti, will we ever find a parabola in the second and third quadrant? Yes, but that is a grade 11 concept. And if I try and explain it now, I'm going to lose you like way over there. So let's not go there just yet. We're going to stop here for now. Okay. We're not going to do that just yet. Okay, we'll get to that later on. All right, yes, Ndwendle. Can you unmute for me, my sweetie? Namisile, I did see your question, my sweetie. I'm not ignoring you. I just need to catch up with everything, okay?
Ma'am, so in an exam or a test, they had to ask us what type of graph it is. How would we describe what kind of parabola it is?
Okay, so if they say, they probably wouldn't ask you what type of parabola it is, okay? Because that's not the point of this. The point of it is that it's just a shape. Okay, so the parabola is a shape. The things that they would possibly ask you about is this value in the front. We're also going to add another number at the back in a little bit. They will ask you more about those things than they would ask you about the shape. If they ever said comment on the shape, you could easily just say it is a positive graph, so the parabola is concave up. Okay, we can say that the parabola is concave up. Okay, because it's facing, it's open upwards. And over here with our sad face parabola, this would be concave down. Okay, not
Thank
clown,
you,
down. Down. All right, excellent, my sweetie.
Thank you.
Awesome. All right, Namisile, what's up, my sweetie? I'm here.
Okay, ma'am. So, okay, load shedding interrupted me. I left when you said it was a smiley parabola. So I don't know where you got the down-faced parabola. I just see the y is equals to -1 and everything, but I don't understand how you got it.
Okay, cool. All right, I want you to compare these two graphs that we've got here. Okay, have a look here. Okay. You notice how over here I've got y is equal to x squared, and over here I've got y is equal to negative x squared. We know that this one is then positive. Yes?
Yes.
It's positive. So the positive one is the smiley one that we're looking at over there. Right. Now the negative one, which way do you think the negative one is going to look?
On the negative, where there's the, what do you call the sad-faced parabola?
Yes, the sad-faced one. Good. So we're just comparing the two, the positive facing one and the negative facing one. Okay.
Oh, okay. Okay, thank you.
Does that make sense?
Yeah, it does. I just wanted clarification on that. Thank you.
No worries, my sweetie. Excellent question. Love it. Awesome stuff. Jasmine, what's up, my sweetie?
In one of the explanations, you said the number at the back of the equation, when y is equal to x or anything, you mean the q value?
The q value, yes. We're going to get there in just a little bit. Okay, but some people haven't seen this before, so I need to take it like baby steps so that other people don't get confused.
So
okay,
but we're going to talk about it because I've been doing work on my own, so I'm also asking questions.
Absolutely. Yes, 100%. You'll see just now when I drop my screen, the Q is going to come up. Okay. Excellent. And then I'm going to ask you to raise your hand and you must explain to everybody because now Jasmine knows all the answers. So she must just do the job for me so I can take a break every now and then. All right. Let's compare this graph over here of y is equal to 3x. And I want us to compare it to the graph of y is equal to x squared. Now, Misila's like, be patient with us. We know you know the stuff. All right, we're going to compare these two graphs. Now, remember, guys, we've already drawn the graph of y is equal to x squared. We know that it starts at 0, 0. It goes to 1 and -1, and it goes all the way to 1. So this graph would have a point there, and we would draw it like that. Right? And by the way, guys, remember, when you're drawing your graph, please don't draw your graph like this. Don't do this. Don't draw straight lines. Okay. Do not draw straight lines. Your lines must curve. You will be penalized if you draw straight lines. No worries, Sia, welcome. I love how he's like, and our perfect Jasmine. Okay. You will be, your marks, you won't get the marks. If they say sketch the graph and you do this, look at me now erasing things. If you do this, straight line, straight line, straight line, they're going to mark you wrong. Okay, Rebetu says, why, ma'am? Because if I had to do this, Rebetu, if I had to find the value where x is equal to 1/2, where x is equal to a half, the value would not be, if I drew the straight line here, the value for that, for this x is equal to a half would not be here. It's down here because we're squaring. Okay, same with if I had to find the value for a quarter. Okay, the value would not be up here. It would be down here because we've squared the number. So the graph follows the numbers that we use to make up the graph. That's why you can't draw it straight. Do you understand what I'm saying? Okay, so the graph that we have must follow the way in which the numbers come up. So if you decide to draw a straight line, you're actually using a straight line graph on a parabola graph. You're not squaring the answers for y anymore. Okay, I hope that makes sense. All right, now we're going to draw the graph of y is equal to 3x squared. Remember our three numbers. X is equal to -1, x is equal to 0, and x is equal to 1. We're going to use these three all the time, guys. All the time, because they give us a full picture of what's happening on the negative side, on the positive side, and write down our y-axis. All right, so tell me, guys, if my x is equal to -1, what will y be equal to? Now, be careful, Hasna, because I knew you would fall into my trap. Okay, I knew you would fall into my trap. Esona, that's it. What we would get for y, we would have y is equal to 3 multiplied by -1 all squared. -1 all squared would give us 1 times 3 would then give us +3. Not -3, +3. Because -1 squared is +1. +1 times 3 is then +3. Okay, so this would give us +3. When x is equal to 0, guys, what will y be equal to? 0. Good. Okay, and where x is equal to 1, y will be equal to 3. Good stuff. All right, let's see what this would look like if we had to plot it. Okay, so here, 3. There's the point 3. Good. So we're going to start at 0, 0. Okay. Now, when x is equal to -1, y is equal to 3. So that would be up here. When x is equal to 1, y is equal to 3, and that's up here. Now, who wants to comment on what has happened to my graph now? What has happened to my graph? Yo, look at me telling you guys not to draw straight lines, and then that's the first thing that ma'am does. Curve. Guys, I tried. Honest to God, I tried. Okay. All right, Jasmine, tell us what has actually happened to our graph.
The graph is slowly coming more towards the y-axis.
That's it. It's curving in. It's getting skinnier. Do you see that? It's getting skinnier than the original graph. Yes?
And it's both in the positive quadrants.
That's it. But that's because this number here in the front is positive, yes? Which means it must give us a smiley-faced parabola. Excellent. Very well done. Well done. Okay, Esona, I want to ask you another question quickly before we continue. All right. Before we continue, I want to add on the graph of y is equal to a half x squared. Right, now if I add this graph, Esona, what do you think my graph will look like? Compare it to my original black graph over here, the black graph, and tell me, what do you think the y is equal to a half x squared will look like? What do you think?
Will the graph be like thinner, if I may say? Like, will it shrink like towards the y-axis?
No. Okay, because when the number was 3, this moved closer to the y-axis, right? So it became skinny. But if it's a half, if it's less than 1, what do you think is going to happen in that case?
Oh, it's gonna go wider.
Yes, it's going to become wider. Okay, maybe, see, in the other class, I was saying that it becomes fatter. Maybe we should say wider instead. Teacher Nelly, what do you think, Ethona? Because fatter sounds wrong. It sounds so wrong. Maybe let's say it gets wider.
And yeah, wider.
Yeah, let's say wider. Yeah, I like the word wider. Thank you, Ethona. You're helping me stay politically correct. Thank you. Okay,
Ma'am, I have another question.
Yes.
So, ma'am, with the 3x squared, ma'am, so when we put the number -1 as x, ma'am, does the number 2, the power 2, only affect what's in brackets?
Yes, that's it. So we would have 3 open brackets -1 all squared. What is -1 squared?
+1.
+1 times 3
is 3.
3. Okay, and that's why we get +3.
Yes, ma'am. Thank you, ma'am.
Okay, does that make sense? Excellent. Good stuff. All right. Okay, so we know that if I now make these values, if I change these values up, okay, if I now change these values up, if my x is equal to -1, I'm going to get +1/2 as my answer, right? Because -1 squared will be +1 times 1/2 is 1/2, right? And if x is equal to 0, y will equal to 0. And if x is equal to 1, y will equal to 1/2. Okay, give me a thumbs up in the chat if you understand where I got all these values that I've got here. Okay, so now if I had to plot this, there's 1/2 there, 1/2. Okay. All right, Chloe, I see you frowning. So I'm gonna need you to put your hand up, my sweetie, and we'll talk about it. Okay. No, Tiana, x will not be given. Remember, ma'am chose, I chose those values. Teacher Coco said, okay, I need a negative number, I need a number on 0, and I need a positive number. So I've chosen those numbers. If they give you the numbers to use, then use the numbers they've given you. But because I want to see how the graph looks on all sides, I've chosen those 3 numbers. Okay. All right, so now this graph over here looks like that. Okay. Yes, go.
Okay, ma'am. You see here when they say 1 over 2.
Yes.
And then also there x is equals to 1, you got y is equals to 1 over 2. Then I don't understand why you got those things and then number 2 is equals to 0.
Okay, let's substitute. Okay, we're using this graph over here. This one, y is equal to half of x. I mean half x squared. Okay, if we substitute, so I'm gonna get half times -1 squared. What is -1 squared, Chloe?
I think it's 1, yeah, 1.
Good, it's 1. What is 1 times half?
1 times half,
it's just half. It's not a trick question. 1 times a half is a half. Is one
same
of the
thing, yes.
Same thing, right? So here in the middle, I have x is equal to 0. So now if I substitute here, I'm going to get 1/2 times 0 all squared. What is 0 squared?
Still 0.
0.
Okay,
What's
yes,
0 times half?
0 times half.
0 times half is?
It's still like 0 times half. Still the same.
Yeah, it's
doesn't
0.
Change.
It's 0. Good. It won't change. It's 0. Same with over here. If we just take the half times 1 squared, 1 squared is going to give us 1 times a half, which is?
Still the same.
That's a half.
Oh, okay.
So that's where we get these values. The first value will be -1.5. The next value would be 0 and 0.
0, yes.
And the other one would be 1.
1.
And
oh, okay. Thank
making
you,
sense.
now I understand.
And that's how I
Yes.
plotted them.
Your graph
Yeah.
looks like okay. Nice. No. Thanks.
Go. How could you? Oh my gosh, I thought you were on my side, girl.
Ma'am, I'm
Okay,
on your
it's fine
side,
though.
but I'm just sharing the jokes, like one joke.
Okay, it's fine. It's fine, my sweetie.
you.
No worries.
Thank you.
No worries. Okay, excellent. I'm so glad you understand. All right. Okay, so this is what these kinds of graphs look like. Let's mix it up a little bit. Okay, so we're learning a couple of things here, guys. We're learning that this number over here, the number in the front of my x squared, the coefficient of x squared, okay, makes my graph, if it's less than, okay, sorry, if it's positive, if the number in the front there is positive, the number in the front is positive and it's greater than 1, if it's greater than 1, then my graph gets skinny. Okay, if it's positive and it's less than 1, then my graph gets wider. Okay, my graph gets wider. But what happens if this number in the front here becomes negative? What kind of graph will I get? If it becomes negative, what will happen to my graph, Jasmine?
It will become a negative, sad-faced parabola.
That's it. It will be a sad-faced parabola. Good. Sad-faced parabola. All of these positive ones are good. In quadrant 3, in quadrant 3 and 4. Wow. Excellent. I love it. Well done. Sure. Oh, teacher Now's just nice answers all around. Good. Sad face. Right. Now, the value that we put in front of this, it's not actually just a depressed parabola up here. Okay, the value that we put in front of there isn't just the coefficient. We put a value, we actually put a letter for this value. We call it A. So when we don't know what that number is just yet, we will rewrite this as y is equal to ax squared. But before we even put in a value for A, we know what A will look like if the number is greater than 1, if the number is less than 1, and if the number is negative, what will happen? Yes, that's it, Akwando, that's correct. It will become straighter because it's getting closer to the, not just the origin, Akwando, to the y-axis. It's getting closer to this axis over here. Okay, it's getting closer to the y-axis. All right. Nice one. Okay, cool stuff. All right, let's look at some variations. All right, so a second ago, we spoke about this tiny little guy over here. We said if it's positive, he's smiley. If it's negative, he's frowny, right? We said that if it's greater than 1, then it gets skinny. We said that if it's less than 1, it gets wider. Okay, we know all of this about this number in front of x squared. Now let's look at what happens when we add plus q. And Jasmine, I know you know the answer. Okay, I know you know the answer, but I want everybody else to see what happens when we get there. Okay. All right, so I'm going to do this, +1. Let's remove this first, x squared. All right, so let's go back to our original graph, guys. We're gonna go back to our original graph. All right, we're gonna go back to our original graph of y is equal to x squared. Now, if I draw the graph of y is equal to x squared, I have -1 and 1 and 1 over here, and it goes through the origin, it goes to 1 over here, and it goes to 1 over there, and we can draw it like this. Okay. Yeah, guys, like I said, I'm no Pablo Picasso. I'm not the artist of the year. You understand, most you understand. Thank you, Teacher Nelly. Teacher Nelly is just filling in all the gaps for me. I love it. Thank you, Teacher Nels. All right, now if we were to do this one, now remember our three things that we always want. We want x is equal to -1, x is equal to 0, x is equal to 1. Let's substitute, guys, and let's see what happens. Substitute into this one, number 1. If we substitute -1 in there, okay, if we substitute -1 in there, if x is equal to -1, what is y going to be equal to? Y will be equal to what? To 2. Good. Y will be equal to 2. If x is equal to 0, what will y be equal to? Yo, Esona, you are super fast. Yo, that's it. Y will be equal to 1. And if x is equal to 1, y will be equal to 2. Good. Y will be equal to 2. All right. Now, let's plot this. Let's actually see what happens. I'm definitely going to need the point 2 here. I'm about to explain up here. I'm about to explain what it is. Okay. So if we plot this, at the point -1, my y value is 2. So at -1, my y value is 2. It's over here. And at the point 0, my y value is 1. Okay. And at the point 1, my y value is 2. So it's up here. Now, let's put it together. Okay, there we go. Now, what do we notice about the original graph and the graph that I just drew? What do we see? It's technically supposed to be the same graph, guys. I promise. It's supposed to be the same graph. But what do we notice? Ntwentle, what do we notice? Ntwentle, what do we notice about this graph?
Is it the one graph starts at the origin and the other doesn't?
Where does the other one start? If it doesn't start at the origin, where does it curve? Where does it turn?
It curves. I'm not sure.
Okay, over here. Remember the other one, the original graph turned at 0, 0. Where does this one turn at?
1.
Good, at 1. So basically what I've done in Dwente, I've taken my graph and I've moved it up by what? By 1 unit. Do you see that? I've moved it up by 1. So good. So what does Q actually do? Q moves my graph where? Moves the graph? Where did it move my graph? It moved my graph up. Do you see that? But also, if this number was negative, it would move my graph down. Good. So Q moves my graph up and down. Okay. Does that make sense?
Thank you.
Okay, I've lost Ntwentle. She's like, all right, you're very welcome, my sweetie. All right, good. So this Q, what Q does, guys, is it just takes the graph and it moves it up and down. That's all that it does here. Okay, it moves the graph up and down. Now, let's put these two things together. If I put a 2 here, and I'm going to change this number to +3. Okay, let's explain what's happened in this question number 1. Okay, what has happened? What did this 2 do to my graph? What happened to my graph? What has it done? You can either put your hand up or you can write it in the chat. What has 2 done to my original graph? What has it done to the original graph, guys? Who remembers? Yes, Nyeleti, that's it. Ntwentle, what has it done? It's made it?
It's made it wider.
No, remember, it's greater than 1.
It's skinnier.
Good, it's made it skinnier. Good, it's become skinnier or steeper, or it's closer to the y-axis. Right, excellent. Is it a smiley face or a frowny face parabola? Is it smiley? Is it smiling or is it frowning, guys? It's smiley because it's positive. It's smiley. Good. And then I didn't just do that. I added 3 to it. I added 3 to my graph. So what did this 3 do to my graph? Where did it move it? Did it move it up or down? Good. It moved my graph up by 3 units. That's it, Nyeleti. Mwah. Beautiful. It moves my graph up 3 units. Okay, so the A, let's have a look at this formula over here before we continue. Okay, we don't need the graph. The graph was just to let us know what's going on, right? So, oh no, look, now I'm erasing the things. All right, so we said that the graph over here, the A in my graph over here, this determines the shape. This will determine the shape of my graph. The shape of my graph, right? And my Q will determine the shift. Determines shift. Okay, shift up or down. Okay, so if we were to take away anything from today, we must know these 3 things. That if we have an x squared, in our function, this is a parabola. It's a parabola. A parabola. Okay, so it must be a graph that looks like that or like that. The A in this graph determines our shape, and the Q in the graph determines the shift. Okay, give me a thumbs up if everything that I've just explained makes sense. Okay, Teacher Nelly, 100%, we're going to talk about turning points on Monday. Okay, so I just needed them to understand the concept and then we'll get to the turning points. All right.